Hi students, good evening everyone. Welcome to ACE Engineering Academy, ACE online platform. We are into GATE 2026 Score Booster series, and today we will look into some questions related with communication systems for EC branch. So let us go ahead and see the details here. Now, before going into my subject, let us just see this part. Most of you are already in preparation. You have just 1 month of time. So probably you might have completed your syllabus by this time, and you should know how you have to attempt the paper. So just 2-3 minutes I just want to focus on this point. So what is this safe target score and what should be your action plan? So here when you talk about target score, in my classes also I advise my students, out of your 100 marks, minimum score you have to maintain is 50. I am talking about students who are doing good preparation. So those who are making just a vague attempt, I am not talking about those students. Those who are very serious, your minimum target score has to be 50 marks. Why I am telling is, if you have a reservation, that's a different thing. If you belong to open category, 50 marks out of 100 if you can get, you can go into IIT or best NIT is possible. And the more the marks you get, above 50, the better will be the IIT and the better will be the branch and the better will be your placements. So this is a safe score that you have to target. That is the first point. Now, what should be your action plan? So we are having so many different subjects here. So what I want to do here is, I am dividing into 3 different slots. Okay, the total syllabus that you have under EC branch, these subjects, Max, Networks, right? Are you all able to see the screen? I am just having some network lag here, so I am just waiting. Are you all able to see my screen? Yeah, okay, fine. Just you can make a chart if you have any problem. Okay, right. So we have considered the safe target score as 50 marks out of 100. That is the minimum marks you have to get so as to enter into IITs or best NITs. The more the marks you get, the better will be the branch, the better will be the placement. Okay. Now, That is your target score. Now, what about the action plan? So, how you have to see that after doing the preparation, your score minimum has to be 50 marks. That is our requirement also. So, here we are having subjects networks, mathematics, controls, digital. So, these 4 subjects make it as a compulsory subjects, because you are going to get around 35 marks to 40 marks from these subjects only. Okay. Now, the remaining I am considering as signals and systems, communication systems. This is one group of subjects, and electronic devices and circuits and analog circuits as another set of subject. So, if you take the weightage, average weightage coming in the last 4 to 5 years, signals and systems and communication systems clubbed together, you are getting around 20 to 22 marks. And if you take EDC and analog, EDC is coming around 6 or 7 marks, analog is coming around 10 or 12 marks. That means around 19 to 20 marks. Generally, the weightage for these subjects is like this. I am taking the average of last 4-5 years. So, what you have to do here is you take any one combination. Either you take signals and systems communication as one combination, or EDC and analog circuits as one combination. That means you are having 20 marks attempted from this area. Okay, and we are having one more technical subject, EMTL, electromagnetic theory and transmission lines. Now, this also has a good weightage. You are getting around 8 or 9 marks from this subject. But the problem here is the syllabus in this subject is very high. It's a very important and interesting subject, but the problem is it will take more time. So, minimum requirement I am talking 35 to 40 marks coming free from these 4 subjects, 20 marks either this slot or this slot. EMTL, even if you take minimum understanding of the subject and attempt, at least 4 marks will be there in your hand. Okay, and last part is your aptitude. So, it covers all that general part and your English part and this area. So, this is covering around 15 marks. I am assuming you can score at least 10 marks. That's all. So, see how clear the strategy is when you go in this direction. So, what we are doing, we are trying to filter out these areas. Now, you tell me what is happening here. You are taking 35 to 40 marks from the first block, and you are taking 20 to 24 marks in the second block, and you are taking around let us assume 10 to 12 marks in the third block. So, what is happening to your net score? If you take the sum of these, this is 55 plus 10, 65 marks to this is 64 and 76, that's it. So, you can see how beautiful this marks that you are attempting. So, if you are in a position to attempt minimum 65 marks of your paper, how many subjects you are planning? 4 plus any 2, 6 plus this part, that's it. EMTL or this aptitude part, or whether you take this part, this one, it's up to you. I am leaving the choice for you only. Even if you do an attempt of minimum 65 marks, definitely there is a very good chance to have 50 marks in your choice. The more the accurate you are, there are some students who call me after the exam and tell, sir, I have attempted only for 60 marks. But I am telling you that person will be a right person to enter into IIT. The reason is their accuracy will be very good. I have seen students who attempted for 60 marks and got 60 out of 60. Damn sure in attempting the question. That should be the mind that you should have. So, try to develop that attitude and don't try to think that I have to attempt 100 marks paper. Student who attempts 100 marks, there is a very high probability that he will completely fail in the exam, disqualified, because he will lose more in the negative marking. So see the things which you are very clear about and focus only on those areas. These 4 are must. Take any one set, either signals communication or EDC analog, aptitude and EMTL, done, that is enough. So at least 6 core subjects and a little bit on aptitude and the EMTL part is sufficient enough for you to enter into the IIT. That should be the game plan. So that is what I want to tell entering before into my communication subject, just to make it very clear for you. Okay, right. Next. So let us see communication systems. My name is Sarvan Kumar. I take communication systems in ACE Engineering Academy, both offline as well as online platforms. So let us see the questions given on this area. So these are the areas that you have to concentrate, because in my communication systems you will be getting around 11 marks to 13 marks. Maximum is up to 13, minimum is 11. And in this the targeted areas, first priority should be noise calculations in both analog communication as well as digital communication. Both the areas you have to focus. Random variables and random processes, then digital communication part. So digital communication part means this covers both baseband data transmission and band pass data transmission. Okay, and analog communication, it is amplitude modulations, then frequency modulation part. So that is one more area, and finally information theory and coding part. So when you do the total preparation of this subject and do the revision module especially, then this is the order of importance that you have to give on these topics. So this is your game plan for communication systems, right. Now without wasting much time, let us directly go into the questions of this area. So first, as per my understanding or my experience, these are the questions that are more likely to come, not the exact question, the model of the questions. So my first priority of area is noise calculations. So let us do numericals on that area. Please see this question everyone, and try to be interactive so that we will have a very good discussion here. Right, please see the question everyone. Yeah, good evening Aman, Jai Prakash. Right, let us see this part. A received signal is plus or minus 1 millivolt for TB seconds interval with equal probability. Now as per our standard understanding, S1 we treat it as bit 1, it is 1 millivolt, S2 we treat it as bit 0, it is minus 1 millivolt, and probability of S1 and probability of S2 are equal, so it is 1 by 2. Standard notations I am using. And the signal is corrupted by additive white Gaussian noise having two-sided power spectral density. So N0 by 2 is 10 to the power of minus 10 watts per hertz. The receiver integrates the signal plus noise synchronously for TB seconds duration and decodes the signal by comparing the integrator output with 0. So basically what is the receiver he is using? Try to understand the way how it is framed. Signal plus noise synchronously for TB seconds. So the receiver integrates, that means he is using a simple optimum receiver. The name of that receiver is also called as integrate and dump receiver. So whenever you come across this word, the meaning is we are using an optimum receiver, and luckily in this question they only gave you the threshold voltage. He is saying it is 0. That means what? When you get the signal R, it is a signal added with noise. So if this R is greater than or equal to 0, you will conform as S1. If this value is less than 0, we will decode it as S2. That's all. That is the algorithm. So you have the transmitter, you have the channel, and then you have the receiver. So one by one you try to list out this, then confusion will not come. You will not make any mistakes. Time is not at all a problem in GATE exam. Accuracy is very, very important. Focus on that. Now what is he asking? The maximum signaling rate in bits per second such that the probability of error is 10 power minus 4 will be dash. Now, what is the formula for probability of error? For optimum receivers, it is Q of root over ED divided by 2 into N0. That is a formula. Okay. Now, what is this value of ED? It is a energy of a difference of the two transmitted signals. So this value will be equal to integrated in 1 bit duration mod of S1 of t minus S2 of t whole square. So you are given data that S1 and S2 are 1 millivolt and minus 1 millivolt. When you take the difference, it is 2 into 10 to the power of minus 3 whole square dt. So this value will be equal to 4 into 10 to the power of minus 6 into dB. Okay. Now, if you substitute these values here, so what is this value now? This value becomes Q of root over, in place of ED, 4 into 10 to the power of minus 6 into TB whole divided by 2 into N0 by 2 is given to you. So what will be N0? It will become 2 into 10 to the power of minus 10. That's all. Is it clear? Now, you are given that this value happens to be equal to 10 to the power of minus 4. That is the data given. Now, to further solve this numerical, you are given that the value of this Q function happens to be 10 to the power of minus 4. If the value inside this root, that means this entire figure value is 3.7. That means if you take the square, that means 4 into 10 to the power of minus 6 into TB, or you can simplify and write 4 and 4 will get cancelled. 2 into 2, 4, 4 and you will get a 10 to the power of 4 in numerator into TB is, I can directly write this as 3.7 whole square, finish. Now what is the requirement he is asking? Maximum signaling rate. Signaling rate means what? Bit rate. So TB is nothing but 1 by RB. So RB you can express as 10 to the power of 4 divided by 3.7 whole square. That's it, over. I hope you are getting all the points very clearly. Okay. Now at this stage you make use of your calculator. Until then don't touch the calculator, it will be waste of time. So let me see what is that value. I am using my mobile for that purpose. So you will get a 730.460. So approximately 730 bits per second, because obviously bits it will not be decimal, so you can directly write the whole number, 730 bits per second. So that would be your correct answer. So hope this question is good. You have understood all the points. You can type your messages here. I can see you. Some students are doing very nice. I appreciate them. Is it clear? Right. Next, let us move on to the next question. See this question. Same model, little bit different. Consider a digital signal detector having an input voltage of plus or minus 2 volts plus noise, where plus 2 volts and minus 2 volts are amplitude of the received signal. Received signal means what here? It is either for S1 or for S2. That means the signal component part he is talking about. And they occur with equal probability. That means I can also write now P of S1 happens to be equal to P of S2 as 1 by 2. That's it. Now, what is the characteristic of noise? Noise is defined as a uniform random variable varying uniformly in this interval between minus 5 to plus 5. So, this is noise in volts, and this is its probability density function. Right. Now, okay, determine the probability of error at the output of the receiver. Now, here when both the symbols S1 and S2 are equally likely, then the threshold voltage, if it is not given, you can always take the average of the two voltages. That means in this case it will be 0 volts. So, this is a very, very important point. When nothing is given, okay, this is how we can analyze the threshold voltage for a digital receiver. That means what is the meaning? If the value of R becomes greater than or equal to 0, you will be decoding it as S1. If the value of R becomes less than 0, you will be decoding it as S2. That's all. So, what is your probability of error now? Be careful. This is a expression for probability of error. Q, previously whatever you have written, this expression for Q function is when noise is Gaussian. But now the noise is not Gaussian, noise is uniform. So, you have to be very clear in which question, which formula you have to use. That makes a lot of difference for you. So, here the formula for probability of error, normal technique, first is the transmission of S1 and probability of error that S1 transmitted is decoded as S2, or probability of transmission of S2 and the probability of error that S2 is wrongly decoded as S1. Did you get my point or not? This is a generalized formula for any case of noise. When your noise is a Gaussian random variable, then you can use Q of root over ED by 2 into N naught. So, try to differentiate between these things so that confusion will not be there. Where, at which point, in which question I have to use that formula. Now, what is the probability of error now? P of S1, you know it is already 1 by 2. Now, what is the probability of error that I have transmitted S1 but it is getting decoded as S2. So, when you have transmitted S1, what is the received voltage? It is 2 volts added with noise. When it will become S2? If it is becoming less than 0. That means, when noise voltages are less than minus 2 volts, there is a likely chance that S1 is decoded as S2. That means, I have to consider a reference voltage here which is minus 2 volts. Now, all these values of noise coming between minus 5 to minus 2 will be my error. So, this will generate an error where I have transmitted S1 but it is getting decoded as S2. Similarly, what would be the probability of error that I have transmitted S2 but it is getting decoded as S1? So, when you have transmitted S2, what is the received signal? Minus 2 added with noise. When it will become S1? If it is greater than or equal to 0. So, this noise value will be greater than or equal to 2 volts. That means, on this if I take a reference point as 2 volts, if my noise voltage comes anywhere above 2 volts up to 5 volts, there is a likely chance that whatever I have transmitted as S2 will be decoded as S1. That's all. So this is how we are identifying the zones. So be very, very clear with what way you are doing the numerical. That should be clear for you. Then only these type of questions you can do with absolute accuracy. Okay. Now, what will be this value? Probability of error for S1 to become S2 is this area. What is this area? Is it a rectangle or not? Base is 3 and height is 1 by 10. Finish. Plus probability of S2 is 1 by 2. And what is the probability of error for S2 to become S1? This area. Base is again 3, height is 1 by 10. So 3 into 1 by 10. Finish. So you will get this value exactly as 3 by 10 or 0.3. That's all. So your correct answer will be option C. So you can understand very clearly both the questions are on the noise part only, but how different they are and how quickly you have to switch between the procedures, that comes on your practice. So there is no much numerical calculation. If you observe carefully, we haven't used calculator also. It is only about how you think and do that numerical. That is what I call it as clarity. You should be very, very clear with these points. Hope you are doing. Okay, fine. Very good. Please do. That's what I am telling. If you are very clear with the subjects, chances of making mistakes does not come. That is how you have to make it clear. Right. Let us see the next question. See this one. Once again I have taken on noise calculation only. Consider a digital communication receiver operating using MAP rule. So this word is very, very important for us. What is the meaning of this MAP? MAP rule based algorithm. So whenever you use this algorithm, the meaning is the threshold voltage you are using in detector is getting optimized. The probability of error values that you are getting minimized, and signal to noise ratio that you calculate at the output of the receiver are getting maximized. So whenever this one line is given in the question, this is the meaning. So automatically it includes all these points. So that is the reason why we prefer using MAP schemes to make a receiver to operate with minimum probabilities of errors. Okay. Now, voltages S1 and S2 are directly given. So S1 is 5 millivolts and S2 is minus 5 millivolts. And they are equally probable. So this is also very beautifully given. P of S1 is equal to P of S2 is 1 by 2. It makes your life very easy if both the probabilities are equal, otherwise it will become more complicated. The channel noise is modeled as AWGN with a two-sided power spectral density of 10 power minus 12 watts per hertz. So channel noise is AWGN. So the nature of the noise is a Gaussian random variable here. For a data rate of 10 Mbps, that means RB is given 10 megabits per second. The probability of error at the output of the receiver is calculated as Q of x. What is the value of x? So because we are using an optimum receiver, we are making use of Gaussian random variable for representing the noise. The probability of error minimum value generated at the output of the receiver will be Q of root over ED divided by 2 into N naught. So, if you see the first question which we have done, that and this are almost the same model. The same question he can frame in this way also, just by using that statement of MAP. So, use this whenever you are having a Gaussian random variable case. Now, what is the ED? Energy of difference of the two transmitted signals means 0 to TB. Mod of S1 minus S2 whole square, 5 minus of minus 5 is 10 into 10 to the power of minus 3. So, it becomes 10 to the power of minus 2 whole square dt. So, this value is 10 to the power of minus 4 into TB. So, this is 10 to the power of minus 4 into TB is 1 by RB. RB is 10 to the power of 7. So, this value will be 10 to the power of minus 11. Finish. Is it clear? Now, what is this probability of error now? Q of root over, in place of ED, 10 to the power of minus 11 divided by two-sided power spectral density is given. So, it is 2 into N naught is 2 into 10 to the power of minus 12. Finish. So, what you will get now? You will get a Q of root over 10 to the power of 12. When it goes to numerator, you will have 10 by 4 means 2.5. Now, what is this value? It is a Q of, now you make use of your calculator, because that is the last step. He is asking what is that X. So, when you make use of your calculator here, root 2.5 is 1.5811. Finish. So, it is a fill in the blank model. So, what would be this value now? The value of X is asking, you can take up to 2 decimals at least, 1.58. So, the same model of questions, if you observe carefully, the 3 questions which you have done till now on noise calculations, you can expect one of this model coming in the exam as it is. We have done with noise calculation considering the channel noise as Gaussian, considering the channel noise as uniform. Other types of random variables can also be used for analyzing the channel noise, but most of the times the common question or the very frequently asked question is when Gaussian noise is used for representing the channel noise or uniform random variable is used for representing the channel noise. If it is Gaussian, you can use this formula. If it is non-Gaussian, we have done this. This is the procedure. So, hope I made it very clear for you. So, these 3 are very important questions. Once you understand this concept, any type of random variable can be used for representing noise. Noise in free space channels is always with a continuous random variable. First priority will be Gaussian, then uniform, then you have Rayleigh, then you may have exponential functions, double-sided exponential or Laplacian function. Any of these things can be asked. The way of solving the numerical will remain the same. Okay? Right, very good. Shall I proceed? Right, see this question, very good question. Now, we have seen with the digital modulation schemes, the first 3 questions which I have taken, noise calculations is with digital communication techniques. Now, this question I would like to do with the analog communication technique. See what is given. You are having the signal coming at the input of the receiver. What is the signal? Is it representing an SSB-SC signal with the transmission of lower sideband or not? AC by 2 m of t cos 2 pi fct plus AC by 2 m cap of t into sin 2 pi fct. And this is getting added with noise. Noise is AWGN. Okay. That means the received signal is sum of modulated signal added with noise. Noise is taking the form of Gaussian. And is it representing a synchronous detector or not? Whatever the demodulator I am showing here is absolutely a synchronous or a coherent detector. Synchronous demodulator. So, it is a product modulator it is having perfect synchronization in frequency as well as phase, multiplied, given as an input to a low pass filter. So generally the cutoff frequency of the low pass filter will be FM hertz, default pass band gain value will be 1. These are all the standard assumptions. Now the output will have your message component. So this is how we consider a synchronous detector or a coherent detector. Okay. Now M of t is a message signal with power 4 watts. So that power of the message signal we write it as PM is given as 4 watts. Okay. And W of t is additive white Gaussian noise with one-sided power spectral density. So directly N0 is given. N0 is how much? 2 milliwatts per hertz. So 2 into 10 to the power of minus 3 watts per hertz. Single-sided power spectral density means N0. Double-sided power spectral density means N0 by 2. And the cutoff frequency of the low pass filter is FM, you can write as 5 kilohertz. That's it. Over. This is the data given. So this is nothing but the bandwidth of your message signal, or the highest frequency component of your message signal. That itself will become your bandwidth of the message signal, and that itself will become the cutoff frequency of your low pass filter. Now, for the above SSB demodulator, output SNR is dash. So he is asking what is the signal to noise ratio at the output of the receiver. That is a bit. Okay. Now, what would be that value? Now, you know very well that the figure of merit for SSB SC modulated signals is always 1. That means the signal to noise ratio at output of the receiver and signal to noise ratio at the input of standard baseband receiver are one and the same. Is it clear? Now, what is he asking? He is asking signal to noise ratio at the output of the receiver. Now, what is the signal to noise ratio at input of receiver? Power of the signal at input of receiver is how much? Obviously, this is your signal. What is its power? AC square m square of t by 2 root 2 whole square, 8 plus AC square m cap of t whole square by 8. Correct or not? Take RMS value of cos and sin, square it, that becomes the power. Now, whether you take a power of the message signal as m square of t or m cap of t square, these values are same. Why? Because the Hilbert transform of a message signal will have effect only on its phase. It has no effect on either energy or power. That means whether you take the power for m of t or power for m cap of t, the value of power remains the same. That means I can write this as AC square into PM by 4. Okay. Now, what is this AC square? AC I have given as 2 volts. So it becomes 4 into power of the message signal is also 4 divided by 4. So the power of the signal at the input of the receiver happens to be 4 watts. Now, what is the power of noise at input of receiver? For any modulation scheme, any analog modulation scheme, for a baseband receiver, the power of the noise is always made fixed at W into N0. So as per the given data, W represents the bandwidth of your message signal or highest frequency component of message signal. And what is N0? You are given N0 single sided power spectral density as 2 into 10 to the power of minus 3. Substitute. So this value will become 10. Clear? That means what is the signal to noise ratio at the input of this standard baseband receiver? signal power you are having 4 by 10, 0.4, finish. Now what is he asking? For the above SSB demodulator, output SNR is dash. So because it's an SSB system, output and input SNR should be same. That means the signal to noise ratio at the output of this receiver has to be 0.4. So this value will remain at 0.4. Is it clear? Yeah, very good. Yeah, Ashok, what you are doing is correct. You can do with any procedure you want, it is up to you. I am not saying what you are doing is wrong, but try to save your time. Go with the simple techniques, don't complicate the given question. That is how you can save a lot of time. Okay, you make use of that figure of merit concept, it becomes simple for you. Why to unnecessarily do block by block, calculate powers at each state and then find signal to noise ratio at the output. You will get the same answers, but this procedure is much more simple than other ways. That is the reason I have selected this procedure. Okay. Right. Next. See one more question on this same topic. This is also noise calculation, and I have taken again on analog modulation schemes. First 3 questions I have discussed on digital communication noise. These 2 questions are on analog communication noise. See here. Consider a message signal m of t having a bandwidth of 10 kilohertz. That means what? Maximum frequency of the message signal, which we write as f max or w, is 10 to the power of 4 hertz. Be very careful. Some students still make a mistake. Bandwidth of the message signal, they write it as 2 into f max. That is wrong. Maximum frequency of the message signal is itself its bandwidth. So it will be at 10 power 4 hertz only. And what is the power? He is saying it is 10 watts. And what is the other data? Maximum possible magnitude of message signal is given to you as 5 volts. Now, what is the normalized power of the message signal? It is represented as PM. Power of the message signal by mod of m of t max whole square. This is the data. Now, what is the power of the message signal? It is 10. Peak possible magnitude of the message signal is 5. When you square it becomes 25. So, you will get a 2 by 5 or 0.4. Is it clear? Okay. Now, this signal is AM modulated with a modulation index of 0.5. So, mu is 0.5. And is transmitted on a channel having an attenuation of 40 dB. So, channel attenuation means channel loss is 40 dB. 40 dB means 10 to the power of minus 4. It is loss. If it is gain, 10 to the power of 4. If it is loss, 10 to the power of minus 4. And two-sided power spectral density. So, N0 by 2 is also given to you. This is given as 10 to the power of minus 10 watts per hertz. Determine the power of signal in watts at the output of transmitter so as to maintain SNR of 30 dB at output of receiver. So, what is the requirement here? The signal to noise ratio required at the output of the receiver is 30 dB. 30 dB means what? 10 to the power of 3 or not? So, even if it takes little time, just write the given data one by one. You will be supplied with some rough papers in your examination hall. So, try to make use of those data clearly so that mistakes will not come. Priority is to minimize the mistakes. I am not saying that you will never get a mistake. Even the person who does very good practice, chances of making mistakes are there, but you have to reduce them. Then only there is a very good chance for you to get very good ranks. Now, what is the logic here? You know the figure of merit of standard amplitude modulation schemes is mu square into Pmn by 1 plus mu square into Pmn. This is a formula. So this is the formula you have to use. If you don't know this, then there is no chance of doing this question. Better leave it. Okay. So what is this figure of merit value now? Mu square is 0.25 into Pmn value is what? 0.4 divided by 1 plus 0.25 into 0.4. So this value is like a 0.1 by 1.1. So you can just write that value if you want. .1 divided by 1.1. So you will get a 0.09. I am taking up to 2 decimals. Okay. That means the signal to noise ratio at the output of the receiver divided by the signal to noise ratio at the input of standard baseband receiver has to be 0.09. So from here what we can write? The signal to noise ratio at the input of standard baseband receiver should be equal to signal to noise ratio at the output of the receiver has to be 10 cube divided by this 0.09, like 1.1, correct or not? Just a moment. So it becomes signal to noise ratio at the output is 10 cube divided by 0.09. So that value is 11. So this will be 11 kilowatts. Now signal power at the input of the receiver I am writing PR. Noise power at the input of standard baseband receiver for any modulation scheme is W into N naught, is 11 into 10 cube. Clear? Is it clear or not? That means what is the power of the signal at the input of the receiver? It should be 11 into 10 cube. The bandwidth of your message signal given to you as 10 to the power of 4 and N naught value is 2 into 10 to the power of minus 10. Finish. So the power of the signal at the input of the receiver PR can be expressed as, you will get a 10 to the power of 7 here. So 10 to the power of minus 3 is there. 22 into 10 to the power of minus 3 watts. Clear? Okay. Now what is the requirement? Determine the power of signal in watts at the output of the transmitter. So he is asking output of the transmitter. That means what is the meaning here? The power of the signal that you get at the input of the receiver is the power of the signal at the output of the transmitter multiplied by attenuation. Attenuation is 40 dB, so 10 to the power of minus 4. So the power of the signal at the output of transmitter will be PR into 10 to the power of 4. So what you will get? It will become 22 into 10 you will get, so 220 watts. Finish. That will be the answer. So this is how you have to analyze before doing the numerical. If you make mistakes, there is a huge chance that you will lose very good marks. So be very careful here. Use your calculator only when it is very much required. Otherwise, don't use calculators. Just try to use it at the last stage. Generally, when you write these gate model exams, maximum 1 or 2 questions you may require a calculator. That is how they will frame also. So you should be in that way of solving the numerical. If you too much frequently use the calculator, one disadvantage is you will lose time because it will take more time, na? And chances of making mistakes also will be more. If you forget 1 0 or 1 point, then entire answer will go wrong. So that is the reason generally try to use the calculator at the last stage of solving the numerical. Okay, right. Very good, very good. Yeah, good Abhishek, what you got is correct. Is it clear? So, we have solved questions related with digital communication noise calculation and analog communication noise calculations. 3 questions I have taken on digital noise and 2 questions I have taken on analog noise. So, most of the times you can see here the channel noise is modeled using a Gaussian random variable case. Okay, right. Now, let us try to see some questions coming under random variables and random processes part, because the time given for this series is only 1 hour. So, whatever the questions that I want to discuss, I have planned it, but due to some time constraint, I can do only some questions. So, whatever that possible is there, I am doing those questions. Okay, right. See this question. This comes under multiple select questions, MSQs. Everyone, please see this question. What is asked, what you have to do? If the power spectral density of a wide sense stationary random process x of t is given, that means x of t is a random process. It will have an autocorrelation function, and the Fourier transformation of autocorrelation function will be the power spectral density. Now, in this question, the power spectral density of this random process is given. It is having 2 components. 4 into del of f is one part, plus 5 into sinc square 5f is another part. That is the data. Okay. Which of the following is are true? So, which of these statements can be true? More than one option might be possible. So, what I am doing here is I am trying to take the inverse transformation, means autocorrelation function. So, you know very well, for del of tau transformation is 1, and for 1 transformation becomes del of f. So, when you have 4 into del of f in frequency domain, what should be the function in time domain? It should be 4. That means the first part of the function will be 4 for all values of tau from minus infinite to infinite. Okay. Now, when you add signals in frequency, it is again adding signals in time. So, plus will be plus only. Now, what is the inverse transformation for sinc square function? You are having a sinc square function defined in frequency domain. So, in time domain, it will become a symmetrical triangular pulse. All these are fundamental things which you should be knowing. So, now I am considering a triangular function in time domain. Here it is tau. So, the coefficient of f is 5. So, it should be from minus 5 to plus 5. And the total area sinc square function coefficient is 5. So, this peak value is 1, that is all. Is it clear? So, this is how you have to find the autocorrelation function first. Now, tell me the statistical parameters. What is the mean value of the random process whole square? It is nothing but the value of the autocorrelation function as tau tends to infinite. Sorry. So, if you consider this value as tau tends to infinite, this function is not there, it is 0. This function is existing. As a tau tends to infinite, that value becomes 4. So, this represents the DC power of the random process or mean value whole square. Now, what is the mean square value of the random process? Means the expectation of x square of t. So, this will be the value of the autocorrelation function at tau equal to 0. So, at tau equal to 0, already you are having 4, this is the value which is equal to 1, that means this value becomes 5. So, this represents the total power of the random process. So, the mean value whole square represents DC power. and value of the autocorrelation function at tau equal to 0 represents total power. Okay. Now, if you have DC power and total power, what is variance? Variance is nothing but total power minus DC power. That means it represents AC power. So, this will be 1 watt. That's all. Now, you see which options are true in this case. Which will be the possible options. So, variance is 1 true, mean value whole square 4 true, mean square value 5 true, and mean is root of this 4. So, it will become plus or minus 2, but he has given it as 4. So, you will have A, B, C as right options. So, A, B and C are correct. So, these type of questions will come for multiple select questions, and more chances are there for these type of questions to come in random variables and random processes topic. So, try to give more emphasis for these statistical parameters. That will be very useful for you. Okay. Let us try to solve one more question. Time is not much for us. So, let us do one more bit in this topic. Now, see here, two systems are LTI and their transfer functions are given to you. So, try to analyze this in terms of a block diagram. It becomes simple for you. So, I am having two systems here. Both are LTI and both are connected in a cascade. So, this is the first system S1 having a H1 of F. Second system is S2 having a system function as a H2 of F. Both are given to you. Okay. Now, input is a random process x of t having some power spectral density S x of F. So, systems are LTI, so the output also will be a random process. Let us assume y of t with some power spectral density S y of F. Okay. Now, if the random process, the output of the system is y of t, determine the power of the output random process. So, he is asking directly what is the power of the output random process. Now, what is your h of f? It would be mod of h1 of f whole square, mod of h1 of f into mod of h2 of f. So, when you square, it will be mod of h1 of f whole square into mod of h2 of f whole square. Finish. That means, when you take mod of this first function, mod of complex exponential is always 1. So, 2 into e power minus j2 pi f mod will be 2. When you square, it becomes 4. Write that into mod of second function is 2 into 10 to the power of minus 1. When you square, it becomes 4 into 10 to the power of minus 2. Write it. Okay. But where is the function valid? This is defined over all frequencies. This is valid from minus 4k to plus 4k. So, the net response is valid only between minus 4 kilohertz to plus 4 kilohertz. Finish. Now, what is your output power spectral density? It would be input power spectral density S x of f is 10 power minus 4 into mod of this h of f whole square 16 into 10 to the power of minus 2. Result is valid when frequency is between minus 4k to plus 4k. Finish. Because your input power spectral density is also valid over all frequencies. So, when you multiply with this function, definitely this will be the result. Now, what is the total power of the output random process? It would be always area of output power spectral density. That means, this value will be, limit will be from minus 4k to plus 4k. And this value is 16 into 10 to the power of minus 6. Okay, df. So what would be this value now? 16 into 10 to the power of minus 6. When you integrate and substitute the limits, you will get 8 into 10 to the power of 3. So the power of the output random process, 16 into 8 is 128 into 10 to the power of minus 3. So that means it would be 128 milliwatts. Finish. So your correct choice will be option B. So this is how you have to solve the numericals. Don't try to keep so many equations and make confuse. You have to see the model of the question very clearly. Systems are given, and very importantly they are given as LTI systems. So immediately you have to switch over to the topic response of linear time invariant systems when input given to it is a random process. So these are all standard formulas that are used while calculating the power spectral densities of the output random process and calculating the powers of the output random process. So if you can understand the flow of that data, then it is very simple for you to do these type of numericals. That is the advantage you will have when you have clarity on concept. So once again I am telling, it is not that you complete the total 9 subjects, technical subjects, and go to your exam. Even if you do 5-6 subjects perfectly, 4 compulsory subjects, maths, networks, controls, digital, and 1 set of subjects, either signals communication or EDC analog, depending on the weightage. Generally the weightage for signals and communication is more. So it is up to you, whatever the interest you have, you can prefer that one slot. So 4 plus 2 became 6. Have a little bit fundamentals on EMTL and aptitude. That is much more sufficient for you to get very good marks. If you have time, you do the total preparation. I am not stopping you, but minimum requirement is what I am telling you here. So if you can score anything above 50 marks, definitely you have a very good chance. When I wrote my GATE examination, I am talking long back, 2008, I am IIT Delhi batch student. So that time I scored only 52 marks. I got IIT Delhi. Now 56 marks, not 52. Now if you see this year record also, you just spend little time on analyzing how many marks which IIT they are getting. Anywhere above 54, 53 or even 50, if you have a reservation, you are very much lucky also. 100% you are getting in IITs. Just cross that border. Okay, the better marks you get, the better IIT, the better branch, and the better placement. Okay, so hope this communication questions which I have solved today are little bit useful to you. Actually, I have so many questions to solve, but due to time constraint, we have to consider only for 1 hour. So hope you have understood these points, and try to make use of this booster series so that you will be in touch with all the topics. Okay, don't waste your time. This coming 1 month is very important. Have good time. Don't waste your time in seeing mobiles, or don't waste your time in chat, especially during this time. Like we have different Telegram channels, WhatsApp channels, so many groups will be there, and they will be keep on posting question solutions. So it is distraction. Stop doing all that. You also don't do any post of questions. Don't reply to any person who is doing that. Simply keep your mobile off. You just keep it in silent mode and do your own preparation. Don't do any group preparation now. It is of no use. Last 1 month, seriously you have to sit with yourself and try to revise all the things what you have studied. Make a very good plan. Eat good food. Don't eat rubbish food, or don't drink like anywhere, any water, any drinks like this. Just try to keep your health as good as possible, because all these things will help you to make get good marks, because ultimately your mind set at the examination time should be very important. So the food, the water, the climate, the way how you do the preparation, the distractions which you are eliminating, all these things will help you to get your marks. The 3 hours will change your entire life. So try to focus on these things. Hope you took this session very seriously, and it will help you a lot. Please concentrate on the things which I have told you. I wish you all the best. Thank you.